So first and foremost that we have to do is to understand that for my project Y, there are only two possibilities. Either मेरा Y continuous data होगा या मेरा Y discrete data होगा. Either that the metric of improvement that I have sought is continuous, mostly like dimensional data, things like flow, cycle time, handling time. There's a continuous quantity as my project Y, etc. So you have Y as continuous, or you are doing a project on reduction of defect count, defect percentage, attrition count, attrition percentage, etc. तो हमारे पास दो ही पॉसिबिलिटी है, या तो मेरे पास डेटा Y कंटिन्यूस हो सकता है या मेरा डेटा डिस्क्रीट हो सकता है. You must realize that when your Y is continuous, you are essentially, when you are talking about something and you are mentioning that as continuous, you must understand that you should have the ability to break the data into smaller constituents without changing the meaning. ज़्यादातर dimensional data will be continuous. Continuous data के साथ एक और आपको attribute दिखाई देगा, that it will always have a unit. Like Sarvesh was mentioning right now, flow का unit हमारे पास kg per hour था. You are mentioning length of something, could be centimeters, millimeters, decimeters or kilometer, whatever. Continuous data के साथ हमेशा you will have some unit associated, and if you are able to break some data into smaller constituents without having to change the meaning, then you are calling that data as continuous. On the other side, discrete data could be of multiple types. All of us can see
Yes, sir.
my screen?
Yes, sir.
Yes, sir. Yeah.
Discrete data could be count, could be percentage, could be binary, could be nominal, could be ordinal, could be attribute. This is the 6 different type of discrete data available to us: count, percentage, binary, nominal, ordinal, and attribute. And unless you are able to clearly categorize your data into continuous and discrete into these 6 heads, you will often make mistakes in choosing the right hypothesis test. So it is extremely critical that you work at identifying your data type before you delve into the tests deeply. Do you guys have any questions on the data type, Sarvesh,
No,
or
I'm
anyone
clear.
else?
No, sir.
No. Okay.
So I have a question on one thing you shown above, where you were trying to say that finding the factors by SciPoc. So how do we find factors by SciPoc?
जब आपने SciPoc बनाया है, and just in case you have created a detailed SciPoc, you understand SciPoc का I
Correct.
is input. If you understand carefully, किसी भी process में one of the key elements of the process shall always be the input involved in the process. तो SciPoc का जो I है वो हमेशा एक key contributor रहेगा to the process performance.
Okay, yeah, got it.
One condition that I had was that my Y and X were both continuous data. At such conditions, मेरे पास the available tests are two. One test which is referred to as correlation, the other test which is referred to as regression. अब हम आ गए प्योर प्ले CY-CX कैटेगरी में, जब मेरा Y और X दोनों का दोनों कंटिन्यूस डेटा है। हमारे पास दो टेस्ट का ऑप्शन है, एक टेस्ट जिसको हम कोरिलेशन कहते हैं, एक टेस्ट जिसको हम रिग्रेशन कहते हैं। प्रीरिक्विजिट बहुत सिंपल है, that both your Y and X must be continuous, and the data visualization tool that we will use will be a scatter plot.
Yes, sir.
You guys are with me so far?
Yeah.
Okay. So first category, we started with the thought that मेरे y के साथ दो ही पॉसिबिलिटी है, या तो मेरा y कंटिन्यूस डेटा है और दैट इट इज डिस्क्रीट डेटा. इफ माय y इज कंटिन्यूस डेटा, देयर आर ओनली टू पॉसिबिलिटीज, या तो मेरा x डिस्क्रीट है या मेरा x कंटिन्यूस है. आई एम फर्स्ट लुकिंग एट the first subgroup, which is y is also continuous and x is also continuous. In that condition, I have two options from the hypothesis testing perspective, one which is referred to as correlation test, the other which is referred to as the regression test. And the data visualization tool or the graph that I can build in CY-CX condition is referred to as the scatter plot. Now let's look at correlation as a test.
Which one you're talking about?
The data that AIG has provided you. कोई भी
No, I don't have it.
वाला
Consent.
data, or if you want I can quickly mail it to you. Have you guys opened your data file that I sent you? I've opened the same data that I sent across to you on the WhatsApp and the meeting request. If you see the column C9, if you see, I have data in this column C9, which is about the total quantity of broken biscuits in a biscuit manufacturing unit. So C9 is quantity of broken in kilograms, hence it is continuous data. And if I wanted to find out if the quantity of production is a contributor to my project Y, I could look at doing the correlation test. I could go to stats, basic stats, fourth from the last, correlation. And I select the Y and the X. Outcome that you see right now.
Yes, sir.
You guys can see my
Yes,
screen. It is saying Pearson correlation of total breakage and production is 0.289. P-value is 0.00. So when you are looking at the correlation test, the first thing that you should start with will be the p-value. P-value here is less than my alpha value, less than 0.05. Hence, alternate hypothesis is correct. Like in this case, P is less than 0.05, hence HA is true. In the case of correlation test, null hypothesis says variables are independent alternate says if you carefully look at what I am saying is I am not using the term dependent. I'm not saying X impacts Y. This is one of the greatest disadvantages of correlation test. It works at identifying whether the variables X and Y are related, but it is unable to verify the causal relationship between variables. It is not able to decipher whether production impacts total breakage or total breakage impacts production. It treats both as variable. This is a huge disadvantage. The third thing that you should look at is the Pearson's correlation value of that is being published. Pearson's correlation, or R as it is commonly referred to as, this value varies from +1 to -1 through 0. If your value is close to +1, it means strong positive correlation. If the value is close to -1, it means strong negative correlation. If the value is close to 0, it means no correlation.
Yes. Yes, sir.
Simple है?
Yeah.
So you will have to start with looking at मेरा p value कितना है. मेरा p value अगर 0.05 से छोटा है, it means that alternate hypothesis is to be accepted. Null alternate क्या बोलेगा? Null will say that variables are independent. Alternate बोलेगा variables are dependent. Basis which you will decide. तो यहाँ हमारा alternate hypothesis true है, which means that we will decipher that variables are dependent to each other.
Sir, हेलो सर, इसमें एक्चुअली पी वैल्यू इज 0.005 से हमारा लेस है, तो देन वी कंसीडर दैट कि यस इट इज इम्पैक्टेड, मींस वी आर नॉट व्हिच वन इज इम्पैक्टेड टू whom, बट यस इट इज इम्पैक्टेड. लेकिन हम अगर वैल्यू यस यस
So we will not say
yes variables are
not use the
related
term
dependent,
impacted. Let's say that the
related, yes.
variables are
So
related.
लेकिन इसमें हम r
Variables
वैल्यू
are
अगर
dependent.
देखते हैं दैट इज नियर टू 0 एक्चुअली. हाँ, so हाँ,
Correct. So I will say
very small correlation.
very small correlation.
So in that case, we can take the decision. We can leave it also from the final action plan if it is not that.
Let us not jump the gun, Pramod ji. Let us not jump the gun. We will थोड़ा सा क्लास हम आगे बढ़ जाते हैं. Then we will discuss this question कि हम वो decisions कैसे लेंगे. We will decide that. अभी तो हमको ये दिख रहा है कि mild positive correlation है. Period. अब आपको इसको ड्रॉप करना है. पहले मैं सारे एक्सेस इवैल्यूएट कर लूं, उनमें प्रायोरिटाइज कर लूं कि किसका ज्यादा इम्पैक्ट है, किसका कम इम्पैक्ट है. Maybe I would want to build two axes together and then see the impact. I could do multiple things, but for right now, मुझे तो बहुत सिंपल चीज दिखाई दे रही है that I am only looking at
okay.
understanding the test first. मेरे टेस्ट ने मुझे ये बताया that my p-value is less than 0.05. पहला चीज मैंने जो देखा, I saw that my p-value was less than 0.05. If less than 0.05, I will conclude HA is true. If equal to or more than 0.05, I will consider HO as true. We should realize that when I am doing this test, next I will check for the Pearson's correlation coefficient. तीन वैल्यूज होती हैं, +1 के पास would mean positive correlation, strong positive correlation, -1 के पास strong negative correlation, 0 के पास no relation. अब आपको डिसाइड करना है that now in this case I have a p value of 0.289. तो like प्रमोद जी was saying, मेरा वैल्यू 1 के करीब नहीं है, 0 के करीब है. So I will term it as mild positive correlation.
Yes, sir.
Sarvesh, we are good with this? And what is the path that we took? We went to stats. Sarvesh, एक बार करके देखो आप. Everyone, please go to stats, basic stats, correlation, and choose your y and x and conduct this test for the same production and for a couple of others. Okay?
Sir.
Sarvesh, you've done? The next test that we have is the regression analysis. I go to stats, regression and regression. First thing that it is asking me for is response. Response का मतलब y. What is the dependent variable is to be added here. So my total breakage quantity was my project y. मैंने उसको चूज कर लिया और x की जगह पे मैंने let's say machine A चूज कर लिया. या बेकिंग टाइम चूज कर लेता हूं. बेकिंग टाइम चूज कर लिया. I press OK. And I get whole lot of information. पहली चीज जो हमको चेक करनी है will be the p-value of the factor that I have chosen. You guys can see this? Baking time, उसका p-value is coming at 0.032.
Yeah, I can see. Yeah, yes, sir, दिख रहा है.
Or should I magnify? दिख रहा है? Okay. So the first thing when you've done your regression test, the first thing that you should look at is the p-value for the factor, which is 0.032. वो 0.05 से छोटा है, hence we will conclude that alternate hypothesis is true. Here you can clearly see that my p-value is 0.032. इसका inference हमने draw करा that as p-value is less than 0.05, HA is true. Correct, everyone? Null hypothesis in the regression test will say X does not significantly impact my project Y. Alternate will say X significantly impacts my project Y. So this is my step 1. Step 2, the next thing that we will look at is the R square value. R square is a value extremely important to us. It showcases the strength of the relationship. R square is referred as coefficient of determination, and it explains the percentage variability in Y caused by X. Out of the total variation that I have observed in my project Y, look at this number here.
Yes, sir.
All of you can see this SS. This is sum of square. So अगर आप देखो टोटल के पास जो sum of square लिखा हुआ है is 1373.383.
Yes, sir.
Correct?
Yes.
Everyone? और रिग्रेशन के आगे जो सम ऑफ स्क्वायर लिखा हुआ है वो है 30.347. बराबर?
Yes.
Yes. Yes, sir. Yep.
Everyone? Can you do me a small favor, all of you? Can you divide this by this? Can you do sum of
2.2%.
square of regression divided by sum of square of total? Everyone else, please check.
Yeah, 2.2.
So R square is nothing but sum of square of the factor upon sum of square of the total expressed as percentage. And this explains कि total कितना variation था, sum of square total कितना था 1373. उसमें से x की वजह से कितना हुआ बोले 30.34. So it is essentially explaining that out of the total variability that I saw of 1373, x की वजह से कितना हुआ तो बोले बहुत कम हुआ. It is only 2%, 2.2% in our case, which is very very poor. Industry में R square should be as close as possible to 100, but at least 62 तो होना ही बनता है.
Yes, sir. I mean, what is the basic difference between R square and R
anyone?
square adjusted? Okay. Okay.
We have not gotten there. We'll cross the bridge when it comes.
Okay.
अभी तो पहले R square था क्या कि मुझे जो टोटल वेरिएशन दिखा उसमें से x की वजह से कितना था. And please use this information very diligently because आगे के decision making में, improve phase में, in your day-to-day analysis, this is going to be a very important index. This is going to be a very important index. तो R square, which is essentially my coefficient of determination, it essentially explains the percentage variability in Y which is caused by my factor. और जानने की जरूरत नहीं है, but good to know, R square mathematically was equal to sum of square of factor upon sum of square of total. So sum of square divided by n minus 1 is my variance. So यहाँ पे भी जो वैल्यू निकल के आ रही है, it is absolutely good to know information. It is not a need to know information. ये जो ms निकल के आ रहा है, ms is nothing but your variance, sum of square divided by degree of freedom. Residual error का sum of square is 1343.03 divided by 206 करो.
Yes, sir. 6.51.
Guys, are we around?
6.52.
यहाँ हम 30.34 को 1 से करेंगे तो सेम रह जाएगा. So ms is essentially sum of square divided by degree of freedom. F is nothing but ms of regression by ms of error. इन दोनों को डिवाइड करके देखो. ms of regression divided by ms of error.
Same, sir. 4.6.
4.74.
4.6544 something.
4.65.
Check कर भी. So the entire ANOVA table will be calculated this way. डिग्री इसमें इंडेक्स क्या क्या मांग रहा है? वो एक मांग रहा है वो डिग्री ऑफ फ्रीडम. एलिमेंट्स आर वी फ्री टू चूज. लेट्स से आई वांट टू फाइंड आउट सम ऑफ 4 नंबर्स जिसका सम इज इक्वल टू 100. आई वांट टू फाइंड आउट 4 नंबर्स जिसका सम इज इक्वल टू 100. गिव मी रैंडम 4
25
numbers,
4 times.
please. 25 एक और कुछ कर लेते हैं, 30 कर देते हैं. आर यू फ्री टू चूज द नेक्स्ट नंबर व्हेन आई नो दैट दी सम इज इक्वल टू 100? नो. अब तो आपको कैलकुलेट करना पड़ेगा. 3 नंबर्स हमको मिल गए, 25 25 और 30. सो 25 इज 50, 50 प्लस 30 इज 80. वी नो दैट द फोर्थ नंबर हैज टू बी 20. So how many numbers were you free to choose? You were free to choose only 3 numbers out of the 4. That is what is degree of freedom. The number of contributors that you are free to choose in a experiment is referred to as degree of freedom.
Yes, sir.
Yeah. Yes, sir.
Are you guys with me? So degree of freedom of total will always be equal to number of data points minus 1. Degree of freedom of factor will be equal to levels of the factor minus 1. Degree of freedom of error will be equal to degree of freedom of total minus degree of freedom of everything else. Let's look at this. ऊपर
207.
यहाँ टोटल का डिग्री ऑफ फ्रीडम कितना आ रहा है? 207. इसका मतलब टोटल डेटा पॉइंट्स कितने होंगे?
Okay.
208.
Got it.
n minus 1. Yes.
डिग्री ऑफ फ्रीडम का फॉर्मूला क्या था? n minus 1. यहाँ रिग्रेशन करने में जब हम अनोवा करेंगे देन यू विल सी इसका इम्पैक्ट ज्यादा. Let's not digress. Let's come back. I got carried away. So first thing that we will check is to check if what is the p-value. P-value के basis पे we will decide whether null is true या alternate is true. Second thing that we will check is R square. R square should be as close as possible to 100%. Industry benchmark is 62%. अगर R square 62% से कम है, then the industry considers the factor to be not of high magnitude.
Yes, sir.
Yes, sir. Yes, sir.
Everyone, are we together?
Yes, sir.
अगर if you are satisfied with the above two, satisfied मतलब HA आ गया है और R square भी हाई आ गया है. If both are true, so the next thing that we will look at is for the transfer function that the Minitab would have given us. Minitab by default एक मैथमेटिकल इक्वेशन हमको बना के देता है. Total breakage is equal to 7.01 plus 0.226 baking temperature, baking time. पहले तो इस यहाँ बीच का प्लस साइन देख करके मुझे समझ में आ गया that the relationship is going to be positive.
Yes. Yes, sir.
Everyone?
Breakage पड़ेगा.
पॉजिटिव का मतलब अगर मैं बेकिंग टाइम बढ़ाऊंगा
Sorry, sir. एक बार और
टोटल
last
ब्रेकेज
thing.
बढ़ेगा. पॉजिटिव कोरिलेशन का मतलब the direction of movement of y and x will be the same. तो मैं जितना बेकिंग टेम्परेचर बेकिंग टाइम बढ़ाऊंगा उतना मेरा ब्रेकेज बढ़ेगा. और वो इक्वेशन आपको क्लियरली बता रहा है. सो इफ यू वर टू पुट इट मैथमेटिकली, बेकिंग टाइम का अगर कोई वैल्यू हमने डाल दिया, लेट्स से 14 मिनट्स, मुझे एग्जैक्टली पता चल जाएगा कि ब्रेकेज टाइम कितना होगा.
10.73.
Yeah.
Yes, sir. 10.73.
कैलकुलेट करके बताओ. सब लोग करो प्लीज. 13, 14, 15 कितना होगा ब्रेकेज? बेकिंग टाइम बीइंग 13, 14 and 15.
No, sir. Sorry, it was not for this
किसका?
session.
अच्छा. Did you
Yes, sir.
guys get the same value? So मैंने कुछ नहीं किया, मैंने फॉर्मूले में वही ऐड कर दिया जो फॉर्मूला था 7.01 प्लस 0.266 टाइम्स ऑफ माय बेकिंग टाइम. सो बेकिंग टाइम यहाँ मैंने तीनों लिख लिए, उसके अगेंस्ट में मुझे ब्रेकेज कितना होगा.
Yes, sir.
Everyone got this? हम ट्रांसफर फंक्शन तभी यूज करेंगे जब p वैल्यू 0.05 से लेस होगा और r स्क्वायर मेरा 62% या योर ओन कंपनी नॉर्म ज्यादा होगा। अब कोविड-19 के सिचुएशन में यू गॉट अ टेस्ट विच इज ओनली 14% आर स्क्वायर, बट अगेन हमारे पास कोई ऑप्शन नहीं है, सो इवन 14% इज ब्लडी गुड इनफ।
Yes, absolutely.
Yes, sir.
एवरीवन?
Yes.
Yes, sir.
We are good so far, everyone? cy dx, when y is continuous data and x is discrete data. Here, when you are in the cy dx category, you will have to first decide whether you are looking at fixing your problem of centering, or you are looking at working at reduction of variation in your project, while they are somewhat correlated as well. तो पहला क्वेश्चन जो आपको आंसर करना पड़ेगा वो essentially यही आंसर करना पड़ेगा that whether you are looking at fixing the variation issue in your process, or are you looking at reducing variation or your centering. बहुत सिंपल है, जिस भी मेट्रिक का मुझे वो डिसीजन लेना है, I will first draw graphical summary of that metric. Let's say total breakage was my metric under consideration. I have the distribution of the data drawn in front of me. Business has given me a target of 9 kilograms. This red line that I have drawn is the target given to us by our business. While if you see, my mean and median are different than each other, meaning that the data is non-normal. Also, I could look at the p-value here and decide that the data is non-normal. इसका मतलब I will use 11.28 which is my median as the measure of central tendency. So एक और line draw कर लेते हैं. I am not sure 11.28 की 11.2 कहाँ आएगा, but एक guesstimate लगा के मैं So the green line is my current process centering, while red line is my target. It is clearly visible that my central tendency is not, मेरा central tendency is about 11.28. My process requirement is 9, which is saying that my central tendency is also not being able to meet my target. Everyone?
Yes, sir.
So even my central tendency is unable to meet my target. If you be in such a situation, the answer is simple. If central tendency not meeting target, तो आप सेंटरिंग पे प्रोजेक्ट कर लो. अगर सेंट्रल टेंडेंसी टारगेट मीट कर रहा है तो वेरिएशन पे प्रोजेक्ट कर लो. Assume a different situation in our example. assume a situation that हमारा ये target was here, let's say a 12.5 or a 13. The central tendency in that case was 11.28, which is already less than what my target wanted to be. Hence, अब central tendency improve करने का तो कोई सेंस नहीं है. अब तो मैं कोशिश करूंगा कि मैं अपने प्रोसेस का स्प्रेड घटा दूं, वेरिएशन रिड्यूस कर दूं, एंड आई वुड वांट माय एंटायर डिस्ट्रीब्यूशन कर्व टू बी लेस देन माय टारगेट. एवरीवन?
Yes, sir.
तो सिंपल है. If my central tendency is not meeting my target, I will do a project on centering. If my central tendency is meeting my target, I will do a project on variation. So अगर आप centering पे project कर रहे हो, तो हमारे पास एक इंपॉर्टेंट इंफॉर्मेशन है टू वेरीफाई. अगर मेरा y नॉर्मली डिस्ट्रीब्यूटेड है, अगर मेरा y नॉर्मल है या मेरा y नॉन नॉर्मल है, वी अंडरस्टैंड फ्रॉम आवर बेसिक स्टेटिस्टिक्स का क्लास कि जब मेरा y नॉर्मली डिस्ट्रीब्यूटेड होता है तो मीन इज अ गुड मेजर ऑफ माय सेंट्रल टेंडेंसी. So I will use certain mean based tests, also referred to as parametric tests. अगर मेरा y नॉन नॉर्मल है, then I will use median based test, also referred to as non-parametric test. Which means कि मुझे पहला काम हमेशा ये करना पड़ेगा कि मुझे चेक करना पड़ेगा कि मेरा y नॉर्मली डिस्ट्रीब्यूटेड है या नहीं है. So like in our case, we saw that मेरा डेटा इज नॉन नॉर्मली डिस्ट्रीब्यूटेड. इसका मतलब मेरे पास जो ऑप्शन है वो नॉन पैरामीट्रिक टेस्ट का ऑप्शन है. So when you have y as normal data, तो हमारे पास 3 टेस्ट का ऑप्शन है. cy dx, centering, y normal. हमारे पास 3 टेस्ट का ऑप्शन है. एक टेस्ट जिसको हम बोलते हैं वन सैंपल टी टेस्ट, दूसरा जिसको हम बोलते हैं 2 सैंपल टी टेस्ट, और तीसरा जिसको हम बोलते हैं guys, when I'm in my cy dx category and I'm concerned about the centering improvement and I see that my data is normally distributed, then I have 3 tests. One referred to as one sample t, the other referred to as 2 sample t, and the third referred to as one-way ANOVA. Similarly, अगर आपके पास डेटा नॉन नॉर्मली डिस्ट्रीब्यूटेड है, if your data were, if your y were non-normal, like in the case that we are using right now, तो हमारे पास एक टेस्ट है जो है वन सैंपल साइन, दूसरा टेस्ट है जिसका नाम है मैन विटनी, तीसरा टेस्ट है जिसका नाम मूड्समेट है। ये तीनों टेस्ट हैं जो अपने अपने जॉनर में essentially are about verifying comparing mean to something, अगर मीन वाला टेस्ट है, यहाँ मीडियन टू समथिंग। जैसे वन सैंपल टी टेस्ट इज यूज्ड टू कंपेयर मीन टू अ स्टैंडर्ड, टू सैंपल टी टेस्ट इज टू बी यूज्ड टू कंपेयर mean of two groups. One-Way ANOVA compare mean of more than two groups. Similarly, one sample sign, when you are looking at compare median to standard. Mann-Whitney will compare median of two groups. Moore's median will compare median of more than two groups. We are together so far?
Yes, sir.
Yes, sir.
Yes, sir.
Now let's get into detail. So before you get into these tests, one very important concept to understand is confidence interval. अक्सर हमारे पास in statistics we will have a sample and we will be required to make a judgment about population. हमारा subject of interest is never sample, it is always population. तो हमारे पास जब डेटा होगा तो डेटा का सैंपल मीन तो मैं निकाल सकता हूं, बट मेरा सब्जेक्ट ऑफ इंटरेस्ट इज द पॉपुलेशन मीन. फॉर दैट यू हैव मैथमेटिकल फॉर्मूलेज अवेलेबल कि अगर मुझे किसी चीज का सैंपल मीन पता है x बार, and if I am interested in concluding about population mean, सैंपल मीन को देख के हम पॉपुलेशन मीन म्यू कैलकुलेट कर सकते हैं, बट इंस्टेड ऑफ गिविंग अ वैल्यू इट विल गिव अस अ रेंज, अ लाइकली एस्टिमेट where the population is going to lie. That range is what is referred to as confidence interval. So let's say as Maruti I have promised to the rest of the world that मेरे वैगन आर का माइलेज 20 किलोमीटर पर लीटर है. Now to be able to be sure, I did several test runs from the Maruti plant of WagonRs and I took out sample data. मेरे पास अब 25-50-100 रीडिंग्स आ गई. उस 100 रीडिंग से मैंने मीन ऑफ माइलेज तो निकाल लिया, बट ये जो निकला वो सैंपल का माइलेज निकला. So I found out that the sample mileage is 21 or 19, but my interest is population mean. So now that I have a sample mean, and if I were to calculate the population mean, instead of giving a value, it will give us a range. This range is what is referred to as confidence interval. Let me show you this.
Sir, I have a quick question. May not be exactly related to this, but let's say we are trying to do a baselining, and where
अभी 10 मिनट रुक जाइए. Hold your horses for 10 minutes. So let's say मेरे पास प्रोडक्शन का डेटा है और मुझे पता है कि मेरे प्रोडक्शन का मीन इज 271.71. Can everyone see this?
Yes.
वो कह रहा है कि पॉपुलेशन का मीन कहाँ लाई करेगा, बिटवीन 266.57 टू 276.84. दिस इज द कॉन्फिडेंस इंटरवल. ये कॉन्फिडेंस इंटरवल, ये जो मीन आया, ये मीन मेरा x बार है, सैंपल का मीन है. ये वाला जो मीन आया, ये जो सी आई आया, ये मेरा मीन है म्यू, पॉपुलेशन का मीन. सिमिलरली अगर मैं मीडियन का निकालना चाहता हूं, मेरा मीडियन सैंपल में is 279 with 95% confidence. मेरा लोअर बाउंड is 256 and upper bound is 288. So मेरा confidence interval of the population mean or eta it is called, eta is 256 to 288. So it is always going to be a range instead of a exact value. Clear?
Yes, sir. Clear.
So one sample T is to be used when you wish to compare mean to a standard. This standard could be customer target, project target, could be anything else. अभी मारुति वाले एग्जाम्पल में एज अ बिजनेस मैंने खुद से प्रॉमिस कर रखा है टू द कस्टमर दैट प्लीज बाय माय कार, इट विल गिव यू अ माइलेज ऑफ 20 किलोmeters per liter. I can use the one sample t test to verify whether the mean of mileage of my car is 20 or not. Or I have started a Lean Six Sigma project, and as part of my goal statement, I said that broken biscuit को मुझे करंट 11 के मीन से मुझे रिड्यूस करके उसको 9 तक लाना है. नाउ आई हैव कलेक्टेड इम्प्रूव फेज का डेटा. आई विश टू कंपेयर वेदर द न्यू स्टेट इज able to meet the target of 9 kilograms that I said. I will do the one sample t test. Everyone, let's see this. I went to stats one sample t. I wish to compare whether my total breakage is equal to, कंपनी ने मुझे 9 का टारगेट दिया हुआ था. Pressed OK. It is giving me alternate hypothesis. Like always, जो पहली चीज हम देखेंगे वो हमारे पास हमारा p वैल्यू होगा. p is less than 0.05, concluding that मेरा alternate hypothesis is true. Null hypothesis in case of one sample t test will say mean is equal to standard. Alternate will say mean not equal to standard. यहाँ 0.05 से छोटा है, इसलिए we will conclude that alternate hypothesis is true in our case. सब लोग साथ हैं मेरे?
Yes, sir.
टेक्निकली वो कर क्या रहा है टू बी एबल टू टेक दिस डिसीजन? उसके पास कॉन्फिडेंस इंटरवल का इंफॉर्मेशन है. It draws the confidence interval, and if target falls between CI तो वो नल बोलेगा. else alternate बोलेगा. If you look at the CI here, the CI, how much is the CI? 11.07 to 11.78. इसके बीच में आप 9 को घुसेड़ सकते हैं? Can you do you
No.
think 9 will exist between them? No. Hence alternate hypothesis is true. अगर इसी टेस्ट को मैं टारगेट चेंज कर दूं, एंड इफ आई वर टू इंक्लूड अ टारगेट ऑफ 11.5, अब क्या होगा? 11.5 is supposed to be between them, right? Now certainly my p value is greater than 0.05, which means my null hypothesis is true.
Yes, sir.
Yes, sir.
So this is how you use the one sample t test. One sample t test is done when you wish to compare mean to a standard. Step 1 क्या है? मुझे p वैल्यू चेक करना है. बात खत्म हो गया. आपको अगर फर्दर कुछ देखना है तो आप कॉन्फिडेंस इंटरवल को वेरीफाई कर सकते हैं. बस. If you did not specify the target, it will still publish confidence interval, which can be useful in the following ways. You must realize that each time that you are doing a Lean Six Sigma project, the goal of a Lean Six Sigma project must always be outside the confidence interval. तो कभी भी आप जब डिफाइन फेज का गोल स्टेटमेंट बना रहे हो, तो गोल स्टेटमेंट बनाने के पहले, इफ मीन इज योर मेट्रिक, आपको वन सैंपल टी टेस्ट करके देखना पड़ेगा कि व्हाट इज द कॉन्फिडेंस इंटरवल, एंड यू विल हैव टू चूज अ गोल आउटसाइड दिस. सो लाइक हियर, अगर ये प्री प्रोजेक्ट वन सैंपल टी टेस्ट मैं कर रहा हूँ, एंड आई फाउंड आउट दैट my current mean of breakage is 11.07 to 11.78, I must pick up a goal which is less than 11.07. Everyone?
Got it, sir.
Yeah. Yes, sir.
दूसरा इस्तेमाल, CI can be used for baselining. अगर आप माइग्रेशन कर रहे हो, अगर आप कोई नया बिजनेस प्रोसेस कहीं से उठा के ला रहे हो, so how do you set the goal of a new process? तो बहुत सिंपल है, हिस्टोरिकल डेटा का कॉन्फिडेंस इंटरवल देखो. सो अज्यूम करो यही बिजनेस प्रोसेस अब हम एक नया फैक्ट्री खोल रहे हैं, उस फैक्ट्री में हमको ब्रेकेज का टारगेट कितना देना है. सो मुझे मालूम है कि मेरे पास बड़ौदा में एक फैक्ट्री है जिसमें करंटली मेरा ब्रेकेज 11.07 से 11.78 तक है. A factory which is 5 years old is giving this kind of quality. What should you expect the new plant to give you? Unless there are some significant changes made to the new plant, I should expect similar performances. So maybe I can give them a target anything between 11.07 to 11.78.
Probably 11.
Correct, everyone? Why should it be less than confidence interval? It should be within the confidence interval. मैं अगर नए वाले प्लांट का मैनेजर हूं, आई विल ट्राई एंड कन्विंस द मैनेजमेंट फॉर 11.78. अगर आप हेड ऑफ क्वालिटी हो, यू ट्राई एंड कन्विंस मी फॉर 11.07. बट आई विल नॉट अग्री टू रिड्यूसिंग इट. मैं कह रहा हूं कि तू 5 साल से फैक्ट्री चला रहा है, तुझसे इससे कम ना हुआ, और मैं पहले ही दिन मैं तुझे इससे बेटर दे दूं.
But then normally in outsourcing, client gives stringent targets.
ठीक है, आउटसोर्सिंग तो ठीक है. अगर आउटसोर्सिंग है और मैं ये पोज कर रहा हूं दैट आई एम बेटर देन यू, दैट इज व्हाई यू शुड गिव इट टू मी, देन आई कुड प्रॉमिस समथिंग. लेकिन फिर भी मैं कहूं कि जब मैं प्रोसेस ट्रांजिशन करके ला रहा हूं तो यही टारगेट रहेगा. 6 months लेटर दैट कुड बी एन इंप्रूवमेंट टू अ 10 kilogram.
Yes.
You guys with me? Everyone?
So, sir, this is the part for the mobilization team as well. If any mobilization team is getting or transitioning any process, then they also run these kind of tests and negotiate the targets. They should.
They should.
ठीक.
Yes, yes, they should. क्योंकि टारगेट सेटिंग अगर इंकी पिंकी पॉन्की होने
Right,
लगा तो
right.
बहुत डेंजरस हो जाएगा. ठीक है. Next test that we have is a two sample t test. Two sample t test, like the name itself is saying, is to compare mean of two groups where null is saying mean of both groups are same, alternate is saying mean of groups are not same. Let's do this. If you see the data, I have different kinds of machines. तो मैं कंपेयर करना चाहता हूँ mean of breakage between machine A and machine B. I can do the two sample t test. I go to stats, I go to basic stats, I go to two sample t. Pressed OK. फिर वही सबसे पहली चीज देखो p वैल्यू 0.003, मतलब 0.05 से छोटा है, इसका मतलब alternate hypothesis true है, which means that the mean of two groups are different. कौन सा ग्रुप अच्छा कर रहा है, कौन सा ग्रुप खराब कर रहा है? Let us do another photographs to be able to show you this. ये देखो दोनों का कॉन्फिडेंस इंटरवल जो बन के आ रहा है. If these confidence intervals would have overlapped even slightly, जरा ऐसा भी रहता ना तो null hypothesis होता. But currently they are significantly different from each other, and that is why we are concluding that ये दोनों टच नहीं कर रहे हैं एक दूसरे को, इसलिए हम 0.05 से छोटा बोल रहे हैं, and hence we will consider that alternate hypothesis will be true. Are you guys with me? The third test that you have is the one-way ANOVA. You go to stats, ANOVA, depending on what data you have, stacked or unstacked. मैंने सारा data select कर लिया, क्योंकि इस बार comparison is not between two, it is between many. If you see here carefully, confidence interval of this is not matching anyone. Null hypothesis will say that mean of all groups are the same. यहाँ पर clearly दिख रहा है कि confidence intervals don't overlap, and hence alternate hypothesis will be true. One-way ANOVA is checking whether mean of all groups are same or not. Null will say mean of all groups are same. Alternate will say नहीं, कम से कम एक तो ऐसा mean है जो different है. यहाँ हमको बहुत सारे ऐसे दिख रहे हैं जो different है. Hence, we will conclude that
Yep.
alternate hypothesis is true.